Welcome back to configuring Arista's tap aggregation feature. In this lesson, we're going to cover identity VLAN, truncation, and some other Arista tap ag goodness like traffic steering. In newer versions of EOS, we don't have to map tap ports to tool ports just through the groups. We also have the option to send directly from a tap port to a tool port. Let's play around with interface Ethernet 16 and have it send traffic directly to Ethernet 23. We'll get into configuration mode, typing config, enter, interface, Ethernet 16, enter, switch port mode tap, enter, and then switch port tap default, and then the command interface, Ethernet 23, and enter. And then, of course, verification with show run interface Ethernet 16. And in that output there, we can see switch port tap default interface 23. This option is referred to as raw interface allocation. Access lists are another element to Arista's tap ag. For example, we could apply either an IP ACL or a MAC ACL on the ingress or tap port. Let's create an access list. We'll get out of interface configuration mode and into global configuration mode. IP access list, and then we need to give it a name. Let's call it deny-2-foo1. Enter. And here we're going to deny IP from any going to 172.16.0.0/16, enter, and then a permit IP any and enter to catch all the rest of the traffic. And then we need to apply this to an interface. So let's use interface Ethernet 15 because that's one of our tap ports. IP access-group deny-2-foo1. And then we need a direction, either in or out. So in this case, it's a tap port. We're receiving on it. We're going to use the input direction. So just simply in. And then verification, and we've applied that to the interface with show run interface Ethernet 15. And there in the output, you can see the IP access-group deny-2-foo1 in. Another trick we can take advantage of is VLAN tagging. Within Arista's TapAg, the feature is called Identity VLAN. Let's say your security team has decided they need to see every packet that passes through every switch in the data center. If a packet enters the DMZ and is switched into the internal corporate network, then the packet will have been captured at multiple points in the network. It would be helpful if the security team knew where each packet was seen to be traversing. If we assign an identity VLAN as traffic ingresses the tap ports, then we could identify that a packet was mirrored while it passed through the DMZ or when it passed through the corporate switches. Most security tools understand and can make use of this additional tag for identity purposes. To configure identity VLAN, we assign it on the tap ports and allow it on the tool ports. Here in interface configuration mode for Ethernet 15, we're going to type switch port tap identity, and then we're going to give it the number. We're going to give it an ID of 15. And then on the tool port, interface Ethernet 23, we're going to configure switch port tool identity, and then our option here is .1q for the .1q tag. And verification here, show run interface Ethernet 23. And we see on our tool port, we have the switch port tool identity .1q and show run interface Ethernet 15. We see the switch port tap identity 15. We can also use the commands show interface Ethernet 15 tap, enter. And in this output, we see the port, the configured mode, the status. I currently don't have anything connected on it. The port identity, which VLANs we're allowing, the native VLAN, and truncation. We'll get to truncation in a minute. We could also issue this command for tool ports as well. Show interfaces Ethernet 23 space tool and enter. A similar output, the configured mode, the status. Here, if we're allowing ID tags, the VLANs we're allowing, and then timestamping if we're taking advantage of that feature. So how about truncation? Some companies have a policy that full packet capture is not permitted. Perhaps they are only allowed to capture source and destination IP addresses or TCP and UDP port numbers. Arista Tap Ag provides that option with a feature called truncation. Packets can be truncated to certain byte lengths so as to exclude the payload. You may also hear this referred to as slicing. We can do this on our interfaces, so let's go into Interface Ethernet 15, enter, and type switch port tap, truncate, question mark, and after truncation, we have our ranges, 100 to 9236. So here I'm going to pick 108 and then show run interface Ethernet 15 for our verification. And we see, yep, switch port tap truncation 108. Now the command on the tool port's slightly different. So let's go into interface Ethernet 23, switch port tool truncation, and then a question mark here, and we see our egress packet truncation size in bytes is 160. We're simply just going to enter 160 there, and then verification, show run interface Ethernet 23, and enter. And we can see switch port tool truncation 160. Be sure to read through the documentation to get familiar with the feature and any caveats. For example, with the truncation feature, the byte count increments by specific intervals depending on where it's being applied. Finally, the last topic I'd like to cover specific to TAP-AG is traffic steering. Traffic steering adds even more flexibility than simply using groups to associate tap ports to tool ports. This allows you to send traffic to different tool ports aside from the group association. We accomplish traffic steering by leveraging QoS-style class maps and policy maps. Just like in QoS-style class maps, we can use ACLs to identify the traffic. But these ACLs are slightly different than the ACLs you're used to applying for voice QoS or security. First, the traffic steering ACLs do not have an implicit deny any at the bottom, and any deny action in one of these ACLs causes the packets to be dropped immediately. Let's create an ACL to play with. Type exit to fall back to global configuration mode, and type IP access-list, and let's call this tap ag steer. Enter. And here we're going to permit TCP any, and then the destination network 172.16.0.0/16. Here we can use the equal sign, and you can see with the question mark after equals, we have several protocol options that are already defined for us or that we can write in ourselves. So let's pick a couple protocols here. Let's do ms-sql-s. Enter. And then let's do another one, permit TCP from any to 172.16.0.0/16, EQ for equals, and then ms-sql-m, and hit enter. Now we can create our class map that will reference our new ACL. Type exit to get back to global configuration mode and type class-map. And if we use the keyword type and hit a question mark, you can see we can actually specify a tap ag class map. Another question mark is for our match statement. We're going to do match any. And because I like to reuse names in an attempt to make for easy identification, we'll call our class map the same name as the ACL. Here it'll be match any question mark and then our name, which is tap ag steer. Enter. Now in this class map, we need to create a match clause. So if we type match and question mark, we have the option for IP, for IPv4, IPv6, or MAC. So let's type IP, and then we need the access group or access list. That's going to be tap ag steer. Enter. Now we create a policy map that's going to reference our class map that references that ACL. Again, I like to drop out of this mode. You don't have to. I'm going to go back to global configuration mode by typing exit. And here I'm going to do a policy map. And if I question mark that, I have a type. And with that type, I can do tap ag. And then I need my name. Again, to keep it simple and easy to follow in the config, I'm going to use the same name, tap ag steer. Enter. And then here I need to call the class map, which was the same name, tap ag steer. Enter. And now I need a set command. What am I going to set? Well, here I want to set the aggregation group. Let's do a set aggregation-group, and then a group name, we'll call it foo2, and hit enter. So I'm going to drop completely out of this by typing end, get out of configuration mode, just because I like to. Type show policy-map, type tap ag, and here we see our service policy of tap ag steer, if it was configured or applied on any interfaces, and then our class map, tap ag steer, that calls our access list, tap ag steer, and then the stanzas of our ACL. Now we can apply the policy map to an interface. So let's get back into configuration mode by typing config, enter, and then let's put this on interface Ethernet 15. So interface Ethernet 15, enter. Here, the command is service dash policy. And if I question mark that, I have the option of input or type. Put in type, and my type is tap ag. If I question that out, it's going to be on input. And finally, the name, tap ag steer, which is my policy map name. Now, if we issue the verification of show run interface Ethernet 15, we see we have a service policy type of tap ag on input calling the policy map of tap ag steer. As you can see, Arista's tap aggregation solution not only solves our problem of getting a copy of the packets where we need them, but also provides an immense amount of flexibility in steering that traffic to the correct tools. And there are additional features such as time stamping and the GUI that we haven't even gotten into yet. Be sure to review all associated tap aggregation documentation on Arista's website, including the TOI, which stands for Transfer of Information, which is specific to the DANS or Data Analyzer feature set where TAPAG is a part of, and it provides an incredible amount of detail, including the fantastic GUI available to us for TAPAG configuration.